Dear friends, I recently finished reading a book called Naked Statistics, written by Charles Wheelan, an amazing read. And even if you're not a mathematics lover, I would highly recommend you to read this book. Like I always say, my book videos are not about the book review, but about my learnings. So here I go. I'm going to share my learnings with you after reading this book, and I hope you like what you hear. Statistics is a very important discipline. We are actually surrounded by that. The ads we see on the TV, why a particular city is growing at a particular pace, why a particular candidate in election is going to win, which school district is good for your children are all based upon statistical model. And statistics by principle of it works on a sample data. Otherwise, think about this. If I need to do a survey about what kind of food habits Americans have, I have to interview about 330 million people, which is a very costly affair. So what statistics does is it will look for the right profile, right sample of data, and then do a control exercise of interviewing them on the right parameters and then come out with a predictive model of what is the behavior or what kind of food in this particular example Americans would like. Very important phenomena, and believe it or not, based upon the probability model they have, it's quite accurate. While this is all good, statistics, as much as a boon, is a curse as well. Because the statistics, as I told you, is based on numbers. If your numbers are wrong, then your results are wrong. It's like garbage in, garbage out. Or at times, people manipulate the data to project certain things in a particular way. So the biggest learning I have reading this book is that peel the onion leaves, right? Peel the data and figure out how, when they're claiming something and someone is claiming something, what is the basis of that claim, what kind of data they have taken, so that if you are going to decide based upon those data set or statistical model, you are a conscious decision maker. Let's take some example to understand what I'm talking about. Let's say, for example, if you want to know in today's world the top 5 grossing Hollywood movies, and by the amount of dollar it has made, the name that appears is number one Avatar, number two Titanic, if I'm getting it right. Number three is the Star Wars, not Dark Knight. Number four is the Star Wars Episode 4. And number five is Shrek 2. When you look at this entire list, you'll say, well, I can still relate to Avatar, Titanic, or for that matter, the Dark Knight. But Shrek 2, out of all names, how can it be in the top 5 list? Well, it so happens is that Hollywood wants you to know the recent movie to be the famous one so that you can go to the theaters, to the halls and watch them. And what they have done is they have very manipulatively worked with the numbers in a particular way to make the recent movie come first. How? Because if you typically see back in 1939 when Gone with the Wind has come, the ticket prices were 50 cents. At the same time, it is not inflation adjusted. When you do all those adjustments, and if you rewrite the entire episode of the top 5 movies, and then movies are in the rank, number one, Gone with the Wind. Number two is Star Wars Episode 4. Number three is The Sound of Music. Number four is E.T. And number five is the Ten Commandments. Only one movie from the previous ranking has come in here when you adjust it by inflation or by the ticket price or by the economy that you are living in. This is a very critical aspect because if you have sheerly gone by the numbers, then you have a very different picture in front of you. And that's where my first learning comes, which says precision versus accuracy. Precision is when you have data which are exactly right. In this case, the dollar amounts were all right. It's just not that it was inflation adjusted. So it was precise in terms of what they have projected and given you, but it was not accurate. The accuracy basically comes when you take all the data points together and then draw a conclusion. So when you do your data analysis, or for that matter, when you're looking at a report which is going to be your basis of taking a decision, make sure that you're keeping an eye on the precision and accuracy. Okay, let's move on and take a few more examples to learn this even more. Have you heard about that percentage ranking that comes quite often in our life, and how we are swayed by that? An example of that would be, let's say my company has done really well and it comes and says that I'm going to give a 2% hike to everyone. Everyone is happy. We are going to get a 2% hike. But if you minutely look at that particular number, 2% hike for a worker who is earning about 50K in that company versus maybe the CEO who's earning a couple of million is quite different. So 2% on a 50K is about if you do the math, is about $1,000, right? And if you do a 2% on $1 million, the number is quite different. It is close to about $20,000. So there goes the difference. So your CEO will get 20,000, while you will get only about $1,000 if you're earning about 50K. So don't get too swayed by percentage. When we're seeing ads, sometimes they show you percentage, and they say that 95% of the time, let's say for any particular sanitizer, the bacteria was taken out. Question that, understand what is the premise of that, because sometimes they're used to deviate you from what really the actual figures and facts are. There's another aspect of statistics, which is not about manipulating the data, but about how you are looking at the data itself. As I said before, data in and data out. If you have the garbage data going in, you'll have the output as garbage. And for that, I just want to highlight something known as regression analysis, which is very popularly used in statistical modeling and also for some of the machine learning as well predictive algorithms that are used in the world. I know it's a little heavy term, but I'll try to simplify it to the extent possible. Regression analysis predominantly works on finding out the change variable, which is known as a dependent variable, that change that you want to observe, and then it will try to see it against couple of or two or three different independent variables to see that how it will behave in a particular situation. I'll take some example and see the fallacy of that if you don't take the right data in. For example, in the US, if you want to find out that which district or province or let's say county have the highest crime rate, that's what your goal is to find. And then you try to find out how I'm going to find it. And if you base that particular analysis based upon how many police officers you have in that county, that will be a wrong assumption or maybe a wrong assumption. Why? Because typically if you see that where there is low crime, there'll be less police officers. That's the by design how you basically work out. And if you have more police officers, that basically means that there is more crime to it. So only if you want to measure it based upon how many police officers you have a wrong variable to start with and can give a wrong prediction altogether. There could be other socioeconomic reasons, there could be other surrounding reasons which can cause why the crime rates are going up, not based upon police officers in this particular case. Similarly, if you want to find out which school districts are good from a student score standpoint, how they are doing, and if you want to rank and rate them based upon the teacher, for example, you say that certain school districts are really good in the school. In the US, they're known as blue ribbon school, which are the best. And if you go and crown all the teachers over there by saying that you're doing a great job, maybe a disservice to the entire teaching community. Why? Because I think what we need to also understand is socioeconomic setup. Typically, if you are in an affluent neighborhood where parents can give time to their kids, where they have enough money to support them, what typically happens is that their home environment is such that the kids are naturally going to do well in school. And I'm not taking anything away from the teacher, but you have bright students coming in, hence the bright results are coming out. So if you recruit bright students into your school or your universities or your colleges, the results of those students will be much higher than the one that those are in the lower grade schools. The way to measure them is that how is the incremental progress, for example, right? So you have a great teacher maybe in a neighborhood which is not likely to have the best kind of affluent families, and they may have kids coming from disturbed family, but if you measure them in terms of what they were when they came in and how they have improved when they went out, that could be a good measure. So sometimes they are very blinding factors in statistical modeling done as a matter of fact sometimes by bad decision, and sometimes we are also blinded by the sight of what we want to measure. So the third lesson that I've learned is when you're looking for statistical modeling, or for example if you want to do, it is absolutely empirically important at what kind of data you're considering, because if you consider a wrong set of data to conclude on a decision, you may have the wrong set of model. The maths is never wrong. I think the regression analysis, if you do, it will never give you a wrong result. It is a data that goes in that gives a wrong result. So keep that in mind, because all of the formulas are already there. You can use any particular tool or on a piece of paper if you know it, and you can calculate it. But the data that goes in is most important. So that's the next best lesson I've learned. I'll give you another example of where how data can be misused. There is a ranking done in the US I think mostly on a yearly basis. It's done by US News and World Report. Predominantly, what happens there is they rank all the universities in the US in terms of top ranking, right? And it's a data used by a lot of parents, a lot of students to see what are the aspiring college they want to go in. And as they do it, there are multiple factors. I think there are 20, 25 different factors they use. They give a weighted average to those factors and they measure all those, they collect the data, they do the weighted average, and then based upon that, they rank the universities. Fair enough. That's how they do it. But if you dig deeper, the biggest factor that they weigh the most is actually reputation. And if you again take a leaf out of that, how the reputation is found out, reputation is actually peer review. So universities are ranking themselves amongst themselves, the administrative divisions are ranking themselves. It's like a cult and they're ranking themselves. And if it is, that has got the highest weight, you can imagine that what universities will go up in the top. So again, misnomer at times and data could be misused and misrepresented, and we get blinded simply by looking at data. So here's how I want to end this video, that statistics is a very important discipline. You cannot do survey for all the population that you're looking for. They are used in real application. For example, when a drug is going out, when the FDA approves, the clinical analysis is done on a sample population, like the COVID example, right? There are many drugs out there, they do on a sample population and they try and test it out. Very important factor, right, in the medicine world. Similarly, in some of the disciplines that I have spoken on before, there is a scientific method to do so. But the biggest lesson you have to learn is four factors. Number one, data is very important. So if you're doing a statistical model, please make sure that your data, what is going, is accurate. Second is the measuring factors. What you're measuring and what you're measuring against is very important. The police officer example was a classic point where I made. It's a very revealing factor that, by having the number of police officers in a particular county may not decide whether that county is crime free or there are more crimes to it. The third important factor is that data could be misused, so be careful about it, especially when you're looking at an ad. Don't get misled by the data they show. Try to understand how they're showing, what population they have taken, and how they're finding the data out before you take a conclusion on that. And fourth is, statistics is a wonderful field. Learn about it. There are different models, like regression is one I have given you. There's central limit theorem, for example. Learn about it and learn a lot more about how statistics is used, and you'll find it fun when you play with number. I'll leave you with one particular statistical model known as coefficient relation. So if you have Netflix, which I'm presuming in the COVID times logged in the home, I'm sure Prime Video or Netflix you all have used. One of the things that you see in Netflix is they recommend what they think you may like, and that's a very critical aspect to it, right? And how they find it, they find it by correlation. They see your demographic, they take different data points from you, where you live, what kind of salary you have, for example, whatever demographics data they can get, which particular culture you belong to, what kind of background you have, your education qualification, and then what you watch. They take those data and they correlate it with some of your peers. So let's say, for example, I'm watching a particular kind of movie, and let's say I love documentaries. I want to watch historical documentaries. They see my background, they see that I watch that. If they find another person like me from Asian background living in the US, in a particular county with the kind of neighborhood I am in, they will recommend that person the movie that they may like based on my liking, because they are correlating me to the other person. And I'll tell you, in my experience, Netflix recommendation has always worked for me. It's a phenomenal model of how, from a sea of movies and documentaries that we have, they can pinpoint into the ones that you like, and hence they can retain their customer, increase their viewership, at the same time have a delighted customer. I hope you like what you heard, and I look forward to hearing your feedback and thoughts. I'm sure some of you who use statistics in their day-to-day life, please leave behind your thoughts and let me know what you think about it. Thank you so very much for watching. Take care now. Bye.